everybody, this is Unit 5 Video 2, and we are going to start with introducing our trigonometric or trigonometry identities. Okay, so the first thing we're going to do is just remind you of our basic functions, and we're going to take those and turn them into some identities. An identity means that for both sides of the equation are equal, so it is a true equation with any angle that I come up with will work for this. So that's what an identity is. It means all real solutions would work. So in this case, because we're working with angles between 0 and 360 or 0 and 2 pi, any of those angles would work and make both sides of these equations true. So let's get started there. So our basic functions are just reminding us that sine of theta is equal to y over r, or y over our radius. Our radius was our hypotenuse of those triangles. And I can have cosine of theta to be x over r. My tangent of theta was equal to y over x. Then I have my reciprocal functions that we have, which is our cosecant of theta, and that is r over y, and we know that this can only be true as long as our denominator is not 0. We're not worried about our radius being 0, so for sine and cosine we're never worried about our radius being 0 because we really wouldn't have a triangle if we had no radius. It wouldn't extend into any quadrant. And then secant of theta would be r over x, so here we have to remember that x can't be 0. And my cotangent of theta, this is when we have x over a y, and we should consider here x cannot be 0, otherwise we would have an undefined value, and here y cannot be 0, or we would have an undefined value there. So these are just our basic functions that we learned in our first unit. Let's go ahead and I guess we used them in our second unit as well when we were solving triangles. So let's go ahead and move on to some identities. So our reciprocal identities were also discussed in the previous video, video 1 for this unit, but we'll remind you what they are as well. So we have tangent of theta is equal to 1 over cotangent of theta, whereas cotangent of theta is equal to 1 over tangent of theta. So these are reciprocal identities because you're talking about what they are in terms of their reciprocal. We have secant of theta equal to 1 over cosine of theta, and that gives us cosine of theta equal to 1 over secant of theta. And lastly, we have cosecant of theta equal to 1 over sine of theta, and therefore sine of theta is equal to 1 over cosecant of theta. So all of these are reciprocals of each other, and they can be used to help us throughout this unit. So just know their relationships and be able to express any of them in terms of each other. Our quotient identities. This one only applies to our tangent and to our cotangent. So tangent of theta is equal to sine of theta over cosine of theta, and cotangent of theta is equal to cosine of theta over sine of theta. So these are our only two, and they are talking about a quotient because we are looking at how we can define one in terms of a quotient of two others. So tangent is the quotient of sine over cosine. Cotangent is the quotient of cosine and sine. All right, that takes care of those. And the last group of identities that we have are Pythagorean identities. And the most important one is the first one I'm going to give you because we're able to, using the sine and cosine writing method that you practiced in the previous objective, we would be able to do the second two. So they don't have to be memorized. However, that might save you a minute or two if you do memorize them. So our first one is sine squared of theta plus cosine squared of theta equals 1. This is our Pythagorean identity because it holds this sine squared plus cosine squared equals, and it's 1 squared. Well, if you were to go ahead and replace these sine and cosines with the values of the triangles, we would have our x squared plus our y squared, and that would equal, on our unit circle, the radius squared, which is 1. So this works for our unit circle, and that's where it comes from. Pythagorean identity of x squared plus y squared equals the radius squared. We can rewrite these using algebra. If I were to subtract, let me change my color here. If I were to subtract sine squared of theta onto the other side, I could write this as cosine squared of theta equals 1 minus sine squared of theta. The same could be said if I were to subtract the cosine to the other side. I'll write this in a third color. If I were to have subtracted the cosine to the other side, leaving only sine squared of theta over here, I would have 1 minus cosine squared of theta. Again, you only have to remember the one there in the top in red, and the other two are able to be formed just based on subtracting one to the other side and leaving us with the other. So I have these for my first Pythagorean identity. My second Pythagorean identity, again, does not have to be memorized because if I use the sine and cosine replacement method, I don't have to memorize this. And that is the tangent squared of theta plus 1 equals secant squared of theta. So this is our second one. It's a relationship between tangent squared and secant squared. And once again, if I do just a little bit of algebra, I can subtract the tangent to the other side, leaving me with 1 equals secant squared of theta minus tangent squared of theta. So that would be subtracting the tangent and leaving the 1 all by itself on the left-hand side. I guess I could let's see, could I get tangent by itself? Yes, I could get tangent by itself here by subtracting the 1 to the other side. So I can have tangent squared of theta equal to, if I'm subtracting the 1, my secant squared comes first, minus 1. So again, as long as you know the one in red there at the top, the others can be derived from that, and they may prove helpful to you. Our last identity that we need to know, our Pythagorean identity, involves the last two functions not yet mentioned, and that is cotangent squared of theta plus 1 will equal cosecant squared of theta. So once again, I'm going to just use a little bit of algebra here to provide you with other options. So if I subtract the cotangent squared of theta to the other side, I get 1 equals cosecant squared of theta minus cotangent squared of theta. And very last one here, again, if I were to subtract the 1 to the other side, leaving cotangent squared of theta by itself, I'd be left with cosecant squared of theta minus 1 on the right-hand side. So as I stated again and again and again, you really have to know sine squared of theta plus cosine squared of theta equals 1. That is the most important of all of the Pythagorean identities because we can convert the other ones by using the rewrite as sine and cosine method. So once you have these memorized and really understood, then the rest of this portion of the unit should prove to be pretty straightforward.